Hi, good evening all. I'm Dr. Dhandapani. So today I would like to share with you regarding the topic is called FEM analysis of this particular stand. Right? So earlier we have seen the videos like how to create this particular mobile stand and what are all the components which is involved like that, right? So now what I'm going to do is, you know how to create this particular stand, right? And this main application is like to holding the mobile, correct? So what I'm going to do is, I'm going to do the FEM analysis, finite element analysis for this particular stand, whether this will be withstanding this particular mobile weight or not. Okay, suppose if I'm going to hold one mobile on this particular location, if it is holding here, then what will happen? What should be this particular deformation, whether it is holding or not? Or sometimes if I am going to add one more weight on this particular location, this will be deflecting towards, once if you hold more than one mobile, this will be holding like this, and if the weight is maximum, then it will be deflecting towards this direction. So I'm going to analyze by using the software, analyzer software, then I'm going to find out what is the deflection or the deformation when the single mobile is loaded here. And if suppose I'm going to add one more mobile, what should be the load, maximum load, and how it will be deflecting towards this direction, and what is the deformation and stress values, right? So based on that, I have to determine the factor of safety, then finalize whether the two mobiles will be holding for this particular stand, this will be okay, or we need to do the modification or some other stand is required. That is my main objective, right? Okay, let us see that this is my mobile stand. So already we created by using the CAD software. So the mobile stand I can import it in ANSYS software. Then basically what I'm going to do is the same like the material properties I am applying here. And after applying the material properties, then I'm going to solve this particular component. So while solving, we can apply the meshing, because there are three stages is available in your FEM software, like pre-processing, solution and post-processing. So basically pre-processing is looking after the input parameters we are going to apply. It's like Young's modulus, Poisson's ratio, and material properties, all those things. Once this is completed, then the main objective of your finite element analysis method is to do the meshing, because meshing is required to determine each and every steps, each and every nodal points, to determine the displacement and stress values. For that reason, we have to do the meshing operation. Once the mesh is completed, then we can apply the loading condition, where we have to do the load we can apply, because I'm going to do the like the mobile I'm putting here. Because of this, the load will be deflecting towards this direction, correct? Because of the entire structure will be deforming like this. I want to check the same like method or same concept should be in the ANSYS software. So you can see here, this is my model, and I am going to apply the load on this particular location. It will be deflecting towards downward direction. Then after applying the mobile load and all those things, then finally I can arrive the deflection like this. So before the deformed shape, I can see the undeformed shape. This is my undeformed shape. The total deformation is around 5.7 mm. This is only one mobile, the load, right? So only one mobile load I am getting around like 5.7 total deformation, and stress is around like 4.6 megapascal, right? Actual yield strength is something around 20 to 25 like that. So you can get the factor of safety, it is around more than 2.5 or 3 factor safety. We know that like basic physics, like factor of safety should be more than 1. That should be within the limit, and it is safe. If goes beyond that, I mean if it is the factor of safety is less than 1, then that should be failed component. So to avoid such type of failure simulations. Okay, this is my the total deformation, and after deforming, the shape should be coming like that. It is a deformed shape, you can see here. So this is the way it's deformed. So from the total structure, because of the load, it will be deformed towards this direction, correct? Similarly, what I'm going to do is I'm going to apply instead of the single load, I can apply this, I can deactivate it, then this load I can activate. Like this is like I can give the load on more than 2 mobiles or 2.5 times higher than the existing load. What will happen? The load is increased. Because of this load will be increased, the deformation should be acting towards this side. Okay, you can see that this I can apply it, and you can solve by using this like a software applications. Then it is simulating. Generally simulation will be takes place, again I am telling you the 3 phases, 3 stages. And previously also I was explained about what is the FEM basic steps, how discretizing, how the like individually element will be created and how it is solving, then finally how the element will be combined together or assembled together because of the applying loading condition, how the results will be arrived. Now you can check the results, that it's a deformed shape but the value is different. So existing the results will be only 5.7 total deformation, correct, but here you can see that the total deformation is around 19.06. so 19.06 will be, it is a larger deformation, on this particular stand because of the load is increased, correct. And if you check with your factor of safety, this is 19 point something. Suppose say for example you can assume the range between the yield stress is around 16 to 18 or something like that, then what will happen? If your yield strength of the material is 18 megapascal, okay, and whatever the results you can arrive, it is around 19.06, then what will happen? 18 divided by 19.06 something if you apply, then that factor of safety value should be below 1. So it should be in unsafe. So if you get this unsafe result for this particular structure or the stand, what we have to do is we need to do the modification on this particular structure. So based on the results whatever you can arrive, where the maximum stress will be distributed. So we want to minimize this particular stress deformation. In that case what we have to do, you can check with your yield stress value, you just see that where the stress deformation is maximum, so that you can increase the strength and stiffness, then automatically your structure will be strengthened. Then instead of that particular value will be minimized. So based on the results, again you have to calculate the factor of safety value, it should be greater than 1. Then after completion of this, you can do the drawing, modeling and 2D drawings, all those things, go to manufacturing. Finally again you have to arrive this particular shape of the product, but including the strength and stiffness is more as compared to the existing component. Then after you can give this more load on this particular location, you will get the high strengthened and stiffness, then it should not get failed, and moreover there is no larger deformation on this particular stand. So with that I can conclude, based on this any product if you take, you have to do the many type of analysis, maybe a structural analysis, thermal analysis, or computational fluid dynamic analysis, all those things based on your type of application or based on your structures. Then the results you can arrive, you can validate with your existing or experimental approach. Even sometimes you can use by theoretical calculations, validate that, then come to the conclusion. If you want to do any modification is required, you have to do, otherwise it's not required. Then finally you can get a good quality product with the optimized structure. Okay, so if you want to calculate the factor of safety of the final analysis, what we have to do is we know the the formula, it's like factor of safety equal to yield stress by working stress. So yield stress is nothing but the material strength, whatever it is available in your data, right? Suppose say for example in this particular material the yield stress may be 18 megapascal, and whatever the results you can arrive at, it may be something like 5 or 10, something like that. What will happen? Yield stress is above 18 or 18, and whatever the results we can arrive by using FEM software, it should be below 18. What happen if you calculate that value? It should be getting more than 1. So automatically it should be safe design. So then only you will get the factor of safety is greater than 1. If it's not, then less than 1. Always the less than 1 value should be not safe design. It should be failure, right? So based on that, we have to calculate and validate, and final validation, we need to do the modification, and after modeling, we can give for 2D drafting, then finally manufacturing will be started. Okay, so this is a way we can validate by using existing design and modified design, then finally calculating the factor of safety for that, right? Thank you.